Welcome back to Java Internals Crashcasts. I'm your host Sheila, and today we're continuing our journey through the fascinating world of Java concurrency. We're in the second season, focusing on synchronization utilities, and we're diving into the synchronizers chapter. Victor, are you ready to explore the next synchronizer on our list?
Absolutely, Sheila. I'm excited to delve into this topic with you and our listeners. What's on the agenda for today?
Today we're going to unravel the mysteries of the phaser class. But before we get started, let's kick things off with a quiz question for our listeners. Here it goes. In a scenario where you need to coordinate multiple threads that can dynamically join or leave a synchronization point, which would be more suitable, a countdown latch or a phaser?
Ooh, that's an intriguing question, Sheila. It really gets to the heart of understanding the differences between these synchronization tools. I think our listeners will need to consider the flexibility and reusability aspects of both classes to answer this correctly. It's not just about synchronization, but also about adaptability to changing conditions.
Excellent point, Victor. Let's keep that question in mind as we explore the phaser class. To start, can you give us a brief overview of what a phaser is and why it was introduced?
Certainly. A phaser is like a reusable starting line for multiple threads. It's similar to other synchronization tools we've discussed, but with more flexibility. It was introduced in Java 7 to handle situations where you need to coordinate multiple stages of work with a changing number of threads. Think of it as a more adaptable version of the tools we've talked about before.
That's interesting. So, if I understand correctly, a phaser allows threads to join in or drop out as needed. How does this work in practice?
You've got it, Sheila. The phaser keeps track of how many threads are participating, and this number can change over time. Threads can join the group or leave it at any point. This changing participant count is one of the key features that makes phaser stand out from its counterparts.
I see. Could you give us an analogy to help visualize how a phaser works?
Absolutely. Imagine a multi-stage relay race where runners can join or leave at checkpoints. The phaser acts like a flexible checkpoint system. Each stage of the phaser is like a checkpoint in the race. Runners, which represent our threads, can arrive at a checkpoint, wait for others, or decide to leave the race. The race only moves to the next stage when all registered runners have reached the checkpoint.
That's a great analogy, Victor. It really helps to picture the dynamic nature of phaser. Now, could you walk us through some of the key actions threads can take with a phaser?
Of course, let's start with the basics. 1. A thread can signal its arrival at the checkpoint without waiting for others. 2. It can both signal its arrival and wait for all other registered runners to arrive. 3. A new runner can join the race at any checkpoint. 4. Multiple runners can join at once. 5. A runner can signal its arrival and then leave the race, not participating in future stages.
That's quite a few options. I can see how this provides more flexibility than our previous tools. But Victor, I'm curious about something. How does a phaser know when to move to the next stage of the race?
Great question, Sheila. A phaser moves to the next stage when all registered runners have reached the current checkpoint. It's like having an official who keeps track of how many runners have arrived. When the last runner checks in, the official signals the start of the next stage.
I see. And what happens if a runner arrives late after the race has moved to the next stage?
Another excellent point. If a runner arrives late, they're considered to have arrived for the new stage. It's different from our previous tools, where late arrivals might miss out entirely. With phaser, you're always part of the current or a future stage of the race.
Fascinating. Now let's talk about real-world applications. Where might we see phasers being used in practice?
Phasers are particularly useful in scenarios involving multi-step processes or simulations. For example, in a system processing large amounts of data, you might use a phaser to coordinate different stages of the processing pipeline. Each stage could have a different number of worker threads, and the phaser would ensure that all data is processed in one stage before moving to the next.
That makes sense. Are there any common pitfalls or misunderstandings about phasers that our listeners should be aware of?
Absolutely, Sheila. One common misconception is thinking that Phaser is just a more complex version of our previous tools. While it can be used similarly, its true power lies in its flexibility. Another pitfall is forgetting to remove threads from the phaser when they're done, which can lead to the process getting stuck. Always ensure that you're managing your participant count correctly.
Those are great points, Victor. Now, as we're nearing the end of our discussion, let's revisit our quiz question. In a scenario where you need to coordinate multiple threads that can dynamically join or leave a synchronization point, which would be more suitable, a countdown latch or a phaser?
Based on what we've discussed, the answer is clear. A phaser would be more suitable in this scenario. The key is in the phrase, dynamically join or leave. Our previous tool has a fixed count that can only go down, while phaser allows threads to join and leave as needed, making it perfect for scenarios with changing numbers of participants.
Excellent explanation, Victor. To summarize today's episode, 1. Phaser is a flexible synchronization tool introduced in Java 7. 2. It allows for threads to join or leave at any time. 3. Phaser supports multiple stages of execution. 4. Threads can arrive, wait for others, join, or leave at any point. 5. Phasers are useful in scenarios like multi-step processes or data processing systems. In our next episode, we'll be wrapping up our discussion on synchronizers with a chapter summary. Don't forget to subscribe to Java Internals Crashcasts and leave us a rating if you're enjoying the series. Until next time, happy coding!